In this video, we're going to be looking at finding the discriminant of a quadratic. The discriminant of a quadratic can be found by the formula d equals b squared minus 4ac. And it tells us how many solutions our quadratic will have. The solution of a quadratic is where the parabola crosses the x-axis. So where y is equal to 0. So if we find our discriminant and it's less than 0, then our quadratic has no real solutions, which tells us that it never touches the x-axis. If d is equal to 0, we have one real solution, which tells us that it only touches the x-axis at one point. Next, if d is greater than 0, we have two real solutions. So our parabola touches the x-axis at 2 points. Let's look at some examples. In the first example, we have x squared plus 7x plus 12 equals 0. So let's identify our a, b, and c. Our a is equal to 1 because it's the number with our x squared. Our b is equal to 7. Our c is equal to 12. So d equals b squared minus 4ac. So we have 7 squared minus 4 times 1 times 12, which is 49 minus 48, which gives us 1. So d is greater than 0. So here we have two real solutions, which tells us that our graph would cross the x-axis in two places. Let's look at another example. In this example, we have negative x squared plus 4x minus 4 equals 0. So here, our a is equal to negative 1, our b is equal to 4, and our c is equal to negative 4. So we have d equals b squared minus 4ac, which is 4 squared minus 4 times negative 1 times negative 4, which gives us 16 minus 16, which is equal to 0. So here, d equals 0, so that tells us we have one real solution. So that tells us that if we were looking at the graph of this function, it would touch the x-axis in only one place. Let's look at a final example. In this example, we have a equals 1 because there's a 1 with our x squared. We have b equals 0 because there's no number with an x here. And we have c equals 1. So d equals b squared minus 4ac. So we have 0 squared minus 4 times 1 times 1, which gives us negative 4. So d is less than 0. So this is no real solutions.